Our talk is Run Cloud Functions Everywhere. My name is Stewart Reichling. I'm the product manager for Google Cloud Functions. With me, I have
Justin Grayston. I'm a customer engineer based out of London, specializing in telco, media, and technology companies.
Cool. Off the bat, housekeeping. Please rate the session in your app afterwards. We want to know whether you liked it, whether you hated it, what could be better. Questions, feel free to shout them out, or we'll have mics at the end. You can also find us outside, answer anything that you want to know. Cloud Functions. Who here has heard of Cloud Functions? Okay. Decent number of people.
That's not bad.
Pretty much everyone. Nice. Who's actually used Cloud Functions? Also a lot of people. Okay, cool. So we're going to talk about stuff that should be hopefully interesting to you if you've already used the product, and also some sort of more fundamental stuff if you don't really have much experience with it, just to make sure that we have a common sort of base of understanding about what the product does. So Cloud Functions, what do I tell customers when they ask me what it is? One, serverless functions. So it's a managed compute environment. It scales automatically up and back down. You don't get any requests. You're not paying for it. You don't manage infrastructure. It's all a very seamless, straightforward experience. Part of that is this streamlined development model. You just write function code. You issue one command. We're going to walk through that in a couple of minutes. And then you get it running. Very simple. Also, events integration. So triggers to have your function run. You can send HTTP requests, get, post. You get a nice URL. We'll show you that too. We also integrate very nicely with different event sources within Google Cloud Platform. So for example, Google Cloud Storage, you get a file to that. You want to have your function run. Just a very simple example of the type of events integration that we offer with this product. I'm going to talk through some of the stuff that we announced at Next this year, because as the product manager for Cloud Functions, nothing hurts me more than a customer who comes up and says, I really like Cloud Functions, but you only support Node. We support many different languages. This year at Next, we announced Python 3.7 GA, Node 8 GA, Go 1.11 GA. We also announced a private alpha for Java 8. And Go 1.12. I'm going to be putting up links at the end of this session with QR codes so you can snap a picture, get you signed up for those as well. Yeah, Node 10 also in beta. The focus of this talk is actually going to be about Node 10. But the main idea here is we want to provide a very streamlined developer model. It wouldn't really be streamlined if we said, you can only use Node. We want to make sure that your favorite languages, very popular languages, are supported, because this whole experience should be very streamlined, simple, and familiar to you as a developer who likes one of these languages. Second thing we announced. So when we first launched Cloud Functions, we only supported one region, Iowa, US Central 1. We announced 3 new regions at Next last year. This year, we announced also London and Hong Kong. We're going to be adding more regions throughout the year. Would love to hear from you where else you want functions. This helps us prioritize where we're going to next. We also announced a feature called max instances. And these are basically scaling controls. And the idea is when you send traffic to a function, we automatically spin up new instances for you to handle that traffic. Sometimes that's great. Other times, you might want to control the degree to which your function scales. So a great example here is you have a SQL database that can only tolerate up to 10 connections at the same time. Well, if you get 1,000 requests to a function and each of those hits your database, you might break some things. So max instances allows you to say, hey, only spawn 10 instances, and that will allow me to make sure that my serverless stuff works very well with my non-scaling, non-serverless stuff. The last feature that is important here is serverless VPC access. And the idea here is Cloud Functions traditionally has not been able to communicate with stuff inside of your VPC network. We now support this feature, which allows you to communicate with your Google Compute Engine instances. Cloud Memory Store for Redis is a huge one. I hear from customers all the time that they'd love to be able to support talking to their Cloud Memory Store instances. You can now access those from Cloud Functions. You can also access resources in peered VPC networks and on-premises networks that you access through Cloud VPN. Okay, enough recap about the new stuff we launched. Cloud Functions 101. I'm going to walk you through the developer experience so that people can see, what is this thing actually about. this is an example of a function written in Node.js. You export a function called hello world. This specifically is an HTTP function, which means that we want to make the experience very seamless and very familiar, so you get HTTP objects that are familiar to you as a Node developer. Any Node developers in the audience? Yeah, a few. OK, cool. So this is based on Express.js. Express is a popular web application framework, so request and response are objects that are, they're those objects from that framework, so this should all be very familiar. So you write this function, it takes these arguments, and then it sends a message back to the caller, hello cloud next. Very simple, 3 lines of code. The next thing you do is you want to deploy that function, so we provide a tool called gcloud. gcloud is the tool that you use to manage all of your Google Cloud Platform resources. You say gcloud functions deploy. My function name here is hello world. You specify that you want it to use the runtime Node.js 8, and you specify a trigger. This is the HTTP trigger. It's going to give you a URL through which you can access your function. That looks something like region project.cloudfunctions.net/hello world. You can now visit this in your browser. You can curl it, and it will respond back with that message. And so what we showed you here is it's super simple to get started. You write 3 lines of code, you issue 1 command, and from that, you get this thing that just kind of magically works in the cloud. It scales for you. It does the sort of resource-based billing model where you only pay for what you use. And all you had to think about was this tiny little bit of code that you wrote. So these are really simple building blocks, and you can build really powerful things with them. We see a couple of different patterns that customers often use. I hear people ask me, how should I use this product? How should I think about it? So Justin, you want to talk about some of the things you see among customers?
Yeah, absolutely. I mean, cloud functions are really powerful and flexible. But I think these 3 areas are where you see a lot of customers using them. Event-based architectures. So a company based out of London, a media company called 7 Digital, use Google Cloud Storage triggers. And they're using that with cloud functions to create a complete new content supply chain.
Okay, awesome.
And you have another pattern that I've seen quite a lot is where you're decoupling on-prem legacy systems, which have been tied to like consumer-facing apps. And now those systems, you need to keep them around, but they're not web scale.
Right.
So
right.
by using like PubSub and cloud functions, you can then decouple those systems.
Okay, so the idea here is you write a function, you deploy it, you say, hey, I want this function to run when somebody maybe puts a file in Google Cloud Storage, or when someone puts a message on a PubSub topic.
Yeah, so like let's say somebody buys something, that goes into a legacy database. You then put that transaction into PubSub, and then you can have a cloud function that runs and then puts that into, say, Firestore, which is a web scale database.
Cool, awesome. The other category we see often is data processing. So I talked to a company out of Europe, Infarm. They do really cool stuff in the agriculture space. They have farms distributed throughout Europe, and at each of these farms, they have IoT sensors, small devices that transmit messages back saying what the status is of those sensors. And they use cloud functions via a PubSub topic that carries that sensor data to them. They aggregate that data, they put it in different databases, they put it in a dashboard so that they can see the status of their farms across different countries. And so what you see here is a very simple sort of data processing model where you get messages, you're doing light ETL, and then you put those somewhere else. Cloud Function's a great way to glue that stuff together.
Yeah, and cloud automation as well. Another thing that we've seen is where you have multiple cloud products, and you may want to use the cloud functions to glue those products together. So let's say, for example, everything's going into the Stackdriver logs. Somebody creates a VM or a firewall. You can create a filter and create a sink in Stackdriver, which goes to a PubSub topic, and you can tie your cloud function to that PubSub topic. And that cloud function can then check with Cloud Security Command Center, like whether that there's a policy violation, for example, whether a firewall has been created that is too open.
Yeah.
And then then the cloud function can then report that violation.
Cool. Yeah, so Stackdriver, for people who don't know, is this suite of logging and monitoring tools. Pretty much all Google Cloud products are very well integrated with it. The idea, again, is from a Cloud Function, or when a VM spins up, I can go, console log some message. Imagine like console log error. I can then say, hey, I'm going to filter messages that contain error. Based on those, do something. Send maybe an email to your security person or to whoever's in charge of reliability, send an SMS. It's a very flexible way for you to kind of glue together your cloud products and what you're doing in GCP. But it all starts with one simple command, gcloud deploy my function. Gcloud functions deploy my function. And this command, it looks deceptively simple, but it comes with a whole bunch of cool stuff. So for the price of one gcloud command, what are you getting? Clearly, when you write 3 lines of code and type this one command, that's not really enough for your function to then be running in our cloud. So what's happening behind the scenes? One is you have a build step. During that build step, we take your code, we upload it. We then start a cloud build job. Cloud build is our tool, our product that allows you to build containers. We install dependencies. If you're a Node developer, it would use npm install, which is super familiar to you if it's standard Node.js tooling. We add some code that runs your function. We're going to talk about that more in a second. And we build a container. On our infrastructure, Cloud Functions are really just containers running on our serverless container infrastructure. So the output of this step is that you have a container image. It contains your code, some additional code, and your dependencies. What happens next? We deploy your function. Your function, we take that container, we're going to connect a trigger to it. So if you say HTTP, we're going to give you a URL. We're going to create an instance of your function that runs in our data center. We then perform a health check. We make sure that what you gave us can actually run on our infrastructure. And then we start to migrate traffic over gradually. And so now you have this container that is ready to receive requests on our infrastructure. You wrote a couple lines of code, we built a container image, we made sure it actually runs, and now it's ready to run. So the last thing we do is we run it. When you send traffic to it, we route those requests to your function. We auto-scale instances of your function. So if you're not receiving any requests, you have 0 instances, you're not paying for anything, it scales down to 0. You get a ton of requests. We're going to scale up a whole bunch of instances to meet whatever your QPS needs are. We invoke your function when a request comes in, and we generate some logs and metrics. One of the challenges that we hear from customers is around observability, and so we want to make sure that when you're using Cloud Functions, you have a very easy way to see what's actually going on. What are the errors that are generated? What are the log statements that you're outputting? And so again, you went from 3 lines of code, 1 gcloud command, to an auto-scaling function that responds to inbound requests. We handle a lot of the gory details for you so that this is actually very simple. And this is great for most scenarios. When you create a managed product like Cloud Functions, you want to try and solve as many use cases as you possibly can. But often when you're working on a project, you might have one specific need that kind of falls outside of the realm of what is supported on Cloud Functions. And it doesn't happen too often, but when it does happen, it's really annoying. And your resolution there often is, I try to talk to customers all the time. A customer will come to me and say, hey, could you please add this custom binary to my container because I need to have that run inside of it. Well, the way Cloud Functions is built today, what actually would happen if I put that custom binary in there is that everyone's function suddenly has that thing living inside of their container. Clearly, that's not tenable. If it's a hugely popular binary, then yeah, we'll add that to support a lot of use cases. But one single customer's really specific thing is hard to add because I have to convince everybody else that they actually want that. So what if you actually need more control? What if you need more control around building your function? The example of a custom binary is a great one. You want to have something run inside of it. What do you do if the product does not support that? What do you do if you need more control over deployments? So as I mentioned, Cloud Functions is live in 6 different regions. What if you need your function to run in a very specific region for, regulatory reasons? What do you do if your function needs specific resources to run? So a great example is today on Cloud Functions, we offer 5 different instance types ranging in memory from 128 megs all the way up to 2048. Well, what if you need more? What if you need more CPU? What if you need GPUs? Again, you could send me an email and say, hey, I'd really love to support GPUs, and I'll tell you, yes, we'd love to do that too. Might be 6 months or a year from now. Well, you need to solve that problem today. A great way to kind of explain this is to go back to the basics. What is a function? Well, as I explained earlier, it's really just a container, and that runs on our serverless container infrastructure. That infrastructure is managed by Google. Within that container, there are a few different things. One of those is an operating system, Ubuntu in most cases. And this is the value of being on a managed product, is that we patch that operating system for you. We make sure that the best we can, there are no security vulnerabilities in it. All of that stuff gets handled for you by us when you're on a managed product. Inside of that container is also a runtime. In this example, it would be the Node.js binary. If you're writing a Python function, there's Python inside of there. And again, that's managed and patched by us. On top of that, there's this bit of code called the functions framework. And we're going to talk about this in depth. But the main idea is it manages your functions lifecycle. You gave us a couple lines of code. We put in an operating system, a binary. Clearly, that's still not enough to write to sort of make your function available and run it. The functions framework is what does that. And then on top of that, you've got your function code, your dependencies. This might look like a simple Node.js function like the one we have there. You might have a packaged JSON file, which is what you use as a Node developer to specify the dependencies of your function. And this is the part that's managed by you. Let's talk about this functions framework a little bit more. And just to be clear, this stuff is available today. It's a real thing. It is now available open source also. I'll talk about that more in a second. The Node.js 10 runtime on Cloud Functions is based on this functions framework. If you deploy a function today to Cloud Functions and you say runtime Node.js 10, you're going to get the runtime that is based on this function. It's available as an NPM package. NPM is Node Package Manager. You can install it using standard Node.js tooling. And the source code is all available in GitHub. It's an open source project. You can see it. We've had people already contributing issues, questions. You can contribute commits. We love pull requests. And the reason I put this sticker on top about it now being open source is the functions framework has always existed. We haven't always called it the functions framework, but there's clearly always been this code that takes your function and makes it runnable. Now we're making that more of an open source. We're taking that in an open source direction where you have this package which you can install if you want to. It's going to give you some nice benefits, which we'll walk you through. And the code is also fully inspectable so that you could go up and say, hey, actually, this is a great idea. I want to make some slight tweaks. I want to create my own thing. Well, here's a great way to kind of get started with that. So let's talk about exactly what the functions framework does so that you have a good sense of, if I use this code, what's it actually doing for me? And I should also mention that the stuff I'm about to talk about, if you take away two things from this talk, it's one, the functions framework is awesome. The second one is that it's completely optional if you're using Cloud Functions. So you can go on deploying functions the way you always have. You don't have to actually think about this stuff or know about this stuff. But if you do know about it, it can give you some nice benefits. So we've got your container. Within that container, we're going to focus on these top two layers. The first one is your function code. We've already seen this a few times now. Pretty straightforward. It's an HTTP function, Node.js. The functions framework manages your functions lifecycle. And what I mean by that is, okay, the first thing it does is, spoiler alert, it's actually just an HTTP server under the hood. You don't need to know about that, but that server, it exposes your hello world function on /hello world. So if you send it a request to /hello world, it's going to run your function. The second thing that this functions framework does is, if you have a client that sends a request to your function, it sends an HTTP request, well, it's going to take that HTTP request, transform it into objects that are specific to your language, and it's going to invoke and run your function by passing it those arguments. Again, these are Express.js arguments. For Python, these would be Flask arguments. For a different language, they would be something different. But it's very idiomatic. It should feel extremely familiar to a Node.js developer. So that function gets invoked, passes those arguments. Your function runs, and it reaches that res send block. It's going to send that back to the functions framework. The functions framework takes that, transforms it into HTTP, and sends it back to the client. So all this stuff is pretty straightforward. You could write this stuff yourself with a couple hundred lines of code. Nothing too magical going on, but the really nice thing here is I can just write this function, deploy it, not think about any of this stuff, and I'm just thinking about my function. And why that's important is that you really care just, the value you can provide as a developer is in the business logic, in solving the problems that your business faces. You don't really provide too much value by writing an HTTP server and making sure it's exposed and handling marshalling or unmarshalling of arguments. All of that stuff is important, but it's not really what you want to focus on and spend your development resources. So that was a lot of talking. Let's switch to a demo. Justin's going to show you what this actually looks like in practice.
Yeah. Okay, so this is the biggest monitor I think I'm ever going to have. Okay, is that all viewable? Is that clear enough? Yeah, that's big enough. So, simple function. You've seen this time and time again in the deck. Nothing fancy going on here. We've got package JSON, no dependencies. So it's as vanilla as it can possibly get.
Can I mention, again, as a Node developer, like none of this stuff should be surprising to you. This is a Node.js function. It's an HTTP function, exactly what we just showed you. Package JSON is the file that you use to specify some, it describes your module or your function. You can put dependencies in there. All of this stuff as a Node developer should feel completely natural.
Yeah. So first thing we're going to do is we're going to just deploy this function. We're not going to do anything. We've just got these 3 lines of code. We're going to deploy this out. And I'm going to specify the Node.js runtime.
I can see it right here. It's very nice.
OK, talk amongst yourselves. I'm regretting not having a bash script right now.
Okay,
so we've got the runtime, and I'm going to create an HTTP trigger.
And this is using Node.js 10. The slide I showed earlier with code was using Node.js 8. And you're probably looking at this thinking, what's the big deal? I just saw this. Why are you repeating yourself? And that's exactly the point, is Node 10, you just change from Node.js 8 to Node.js 10. Boom, you're good to go.
And we're good to go, hopefully. Here we go. So I'm going to deploy that to US East 1. While it does that, let's switch to a different shell.
Yeah, and so again, you're just deploying the way you normally would.
Yep.
And as I mentioned, you don't need to know anything about the functions framework if you don't want to. This is what you get if you actually do know about the functions framework.
Yeah, so we're going to just npm install any Node.js developer. This is completely, you do this time and time again, functions framework. Okay.
And so what's happening here is you're using the Node package manager to install this package. It's going to add it to your package JSON. See how that just showed up on line 12? And now you're saying, hey, my function depends on this functions framework.
Okay. So that's that installed. We need to do one more thing.
Okay.
We need to add a start script. So that's functions framework.
And I know I'm belaboring this point. As a Node developer, adding a script, super idiomatic. It totally fits the idioms of Node.js. You should already know how to do this. You don't need to learn any complicated stuff. And what Justin is doing here is he's saying, hey, my start command says run functions framework, look for this specific function, and then he's going to specify the function signature type as HTTP. The reason you do this is because we also support an events-based function signature type, and you tell us which signature to use so that we know how to transform incoming HTTP into the right arguments and invoke your function properly.
And because it's completely idiomatic, we can now just do the start script. And what's really cool, without any emulators, I now have my function running locally on my machine.
It's just a local development server, the way you would get if you were using Flask on Python or various other web frameworks. You now have this function that you can send requests to. You can very quickly iterate, even if you're not connected to the internet, you have this thing running locally, you can send it requests, and it will run your code. So that's kind of cool. Knowing about the framework gives you this very simple local development experience that lets you bootstrap a function. And
we should also have the same function running on Cloud Functions.
Yeah, so what you were just seeing on the screen, switch back for just a sec, is this is what the output you get after deploying a function. It sort of describes what just happened some characteristics and attributes of the function. It also gives you this URL, the HTTPS trigger URL. And like people who have worked on provisioning HTTPS URLs know that this stuff is actually kind of a pain. It's not super easy, but we, through our tooling, make this super easy for you. You now have this thing that you can click, you can send traffic to it, you can send HTTP posts, get payloads, and it will just run, and you can grab all of the stuff that comes as headers because you're getting these idiomatic HTTP objects in Node.js or in the language that you wrote your function in.
The functions framework isn't just about running locally, is it?
Right.
So let's go back to the slide deck. Thank you.
Thank you. OK, so run functions in more places, local development. Cool, that's great. But if this were all I was showing you, I feel like you'd be disappointed because the title of the talk is Run Cloud Functions Everywhere. And this is just 2 places. So where else could we run our functions? Well, if you know about Knative, and it's not that important that you know about Knative, I'll explain it briefly. You can also run your functions in Knative environments. Knative environments are environments that run containers that scale automatically, and have, they're basically serverless environments from a developer experience perspective. We announced 2 products that are Knative environments at Cloud Next this year. One of them is Cloud Run. The other one is Cloud Run on GKE. If you don't know what these are yet, I'm about to talk about them. So your Knative environments basically it's a standard for how you run containers in a serverless manner. Your functions scale up, they scale down. There's a serving API to which these 2 products adhere. And we can now take your function with the functions framework and run it in these other container-based environments. Let me recap what Cloud Run is and what Cloud Run on GKE is. So one is it's serverless containers. You build a container by specifying a Docker file. You can now run that on our Cloud Run, our serverless container infrastructure. So you wrote some code, you wrote a Docker file, you did Docker build, or you built it using some other product, and now you deploy that to our infrastructure. That will scale automatically for you. It takes HTTP requests. You only pay for the resources that you use. You can bring your own container. As I just mentioned, you're going to write a Docker file. With a Docker file, if you're not familiar with containers, it's not that scary, but it gives you a huge amount of flexibility. So you can put in that whatever binaries that you want. You can specify specific rules, and it gives you way more control than you can get just by writing some source code. You can say, hey, apt-get install blah, and that will allow you to put custom stuff in there. And then the last piece is, it says Cloud Run and Cloud Run on GKE, and I'd encourage you to read up on Cloud Run or Cloud Run on GKE after the talk. But you have this common experience where you can build a container and deploy it. You deploy it to either Cloud Run, which is a fully managed environment that runs on our infrastructure. It's actually the same infrastructure that Cloud Functions runs on. Or you can deploy it to Cloud Run on GKE, which runs inside of your Google Kubernetes Engine cluster. And why would you want to do that? Well, it gives you an even bigger degree of control, and we'll talk about that in a second. So you've got these 2 environments that can run containers. How do I run my function in those environments? Well, remember that Cloud Functions, when we build your function, it's really just a container at the end of the day that runs on our serverless container infrastructure. You can take full control over that container using the functions framework by specifying a runtime, by specifying an operating system. You can build that container yourself, and now you can deploy that to Cloud Run and Cloud Run on GKE. So whereas with Cloud Functions, you just write some source code, you type a command, and you deploy it. If you want to go down this path, which I think is a super interesting path because it gives you way more flexibility, you can write your function code, add the functions framework, write a Docker file, build it, and deploy it. And it's actually quite a seamless experience. We'll show you that in just a second. Let's switch to another demo.
OK. So same function, slightly modified. If we're going to have a function and we want to make it portable, we don't want to have a hard-coded string. So I've just used an environment variable with a backup just in case I forget to set the environment variable. That's never happened.
So yeah, pretty much the exact same thing, except line 10, rather than saying hello Cloud Next, it takes this message, which in line 1 says, hey, check for this environment variable, or no message set. We're going to set the environment variable.
Okay, so I'm going to deploy this with the environment variable. Because I've already deployed this function, I don't need to specify the runtime. You can do, but I'm going to do region.
Why don't you add the runtime? I think it'll look better on video later.
Okay, I'll add the runtime. Okay, so now we just need to set the environment variable. That's all we need to do.
If you don't do this, it's just going to say no message set. It's not going to be a very nice demo, so please set it.
Okay, I think that'll do.
Yeah.
Okay, let's go ahead and deploy that.
This is the same deployment command as earlier, except we're also specifying the environment variable.
Okay, new shell. While that deploys, okay, let's deploy to Cloud Run. So first thing we need is a Docker file. Super simple Docker file. There's more comments in here than actual actions.
Yeah, there's like 5 or 6 lines
Yeah.
that you actually write. And this is a totally standard Node.js Docker file.
Yeah, and so we're taking Node.js 10 base image.
From the top.
Yeah, Node.js 10 base image, creating a location to run
That's
the
your
app.
operating system, right?
Yep, that includes
Line
the
3.
operating system and the runtime binary,
Yep.
Node. And then we copy the package JSON. We do that in a separate step because if you don't actually update your dependencies, we don't want to rebuild that layer in the Docker container. We copy the function across, and then we have our npm start, like we had running it locally.
Okay, so you specify the operating system, you copy stuff into there, you do npm install to make sure the dependencies are installed inside of that container. And then on line 20, this is just the command that will be run when your container starts up. And now Justin is using Docker, which is...
On the machine.
Yeah, on the local machine. You could also build this in the cloud. Docker is the standard sort of container building and management tool chain. And he's saying, build my container, and he gives it a name. That container gets built. You can see that was super fast because a lot of stuff is already cached because we've done this before.
Maybe.
And then he's going to take that container, which he built locally, and he's going to put that on Google Container Registry. Google Container Registry is just a place that stores containers for you. So right now he's uploading that container. It's going to be on Google Container Registry. It has a name. So he went from function source code, added a Docker file, built the container, pushed it, and now it's ready to be deployed.
So, Cloud Run. It's beta, so we need to add the beta. Okay, this should be looking very familiar. If you used your G-Cloud with functions, this is very familiar, right?
Run to, or
functions
said
to run.
functions, now it says run.
Yeah, that's it. And instead of the function we want to invoke, we just need to give it a service name. It will, if I can type, it will remind you if you forget. I've done that lots. And I'm going to deploy this to a different region, US. Let's go to US Central. We need the image.
Yeah, so rather than specifying a runtime here, he's saying, hey, just take my image from Google Container Registry with this name.
And then, again, very, very familiar. In fact, absolutely identical to what we just did. In Cloud Functions, we set the environment variables. And this time we want to say hello from.
Okay, and so what's going to happen here is once he enters this command, Cloud Run is going to go and fetch that image and deploy it to the Cloud Run infrastructure. We do many of the same things that we showed earlier, where we take that image, we start it, we make sure it's healthy, we start to spin it up for you.
And there's one difference here is by default, services in Cloud Run are private. But for the sake of this demo, we're going to say let's allow unauthenticated.
Yeah, if you didn't do that, it would just give us an error, which should make for a bad demo when we try to...
Okay, so we've got another environment we can deploy to. Now, I'm going to deploy that same function into Kubernetes.
Okay.
So let's sharpen the YAML tools. No, we don't need to.
Yeah, if you've used Kubernetes before, you know you have to write a lot of YAML to deploy something. One of the really nice things about having Cloud Run and Cloud Run on GKE is Cloud Run on GKE is Kubernetes under the hood, but you don't have to actually write any YAML. You get a very seamless developer experience using gcloud, the command line tool. And by the way, you can do all this stuff in the UI too, in the user interface. We're just using gcloud because it lends itself well to a demo, and we see that pattern a lot among developers. And so to do this, Justin, before this talk, set up a Google Kubernetes Engine cluster. You can do that via the UI. That thing is now sitting there. He installed into that Cloud Run on GKE, and it's sitting there waiting for him to deploy a container to it.
Okay, so you can see this is identical, really. So far, there is no difference. Okay, we're going to say hello from
You'll see why we're setting the environment variables. When we show you these things running, it's going to show you this message just so you can make sure that we're not faking it.
Yeah, and the last thing we need to do is we need to actually say which cluster do we want to deploy into.
Okay, so rather than saying, hey, region, which region would be a region, one of the ones supported in Cloud Run in Google's data centers, he's going to say, hey, this cluster, which he's called cloud-run-gke, is where I want to deploy this function to.
And we need to tell it where the master node lives, which is in US West 1A. Okay, let's just double check. I think we're good. So that's going to deploy that out into my Kubernetes cluster. Exactly the same. If I'm a developer and I have an ops team looking after my GKE cluster, I don't need to worry about all of that. It's a serverless experience.
Yeah, that's a good point. Is Cloud Run on GKE? Well, you have to have a GKE cluster. It's not as managed as the Cloud Run experience is. If you already have a cluster, it's a great way to actually get started and get as much as you can out of your functions. If you don't have a cluster yet, say the easiest way to try this stuff out is to just go for Cloud Run because that's fully managed.
Yeah, okay. So let's just recap. We deployed to 3 different environments with exactly the same function. The only different was the environment variables.
Yep.
And we've gone to Cloud Functions, Cloud Run, and Cloud.
Well, you wrote a little Docker file too.
Yeah, I did.
But yeah, it's the same function code.
We didn't have to change the actual code at all.
Exactly.
Okay, so hopefully, if the demo gods are playing nicely, we should say hello from GCF in US West.
Okay, you got a nice HTTPS URL that you can invoke there.
And then we go to Cloud Run, and we head across the US to US Central, and we should have another URL.
Serving traffic at, yep, it gives you another URL.
Yeah, there we go. Hello, Cloud Run in US Central. And then finally, we had the same going into my Kubernetes cluster, which is here, which is already set up. If we come to here, and we paste that in there.
Nice.
From Cloud Run on GK in US West.
Okay, cool. So you just took the same code, you added a framework, and you added a Docker file, and you deployed it to 3 different environments. So we've established that you have portability among these environments when you're using the functions framework and you just want to write functions. Can we go back to the slides, please? So your functions are portable. You can run them on Cloud Functions. You can run them locally. You can run them on these different environments. But like, what's the big deal, right? Like portability, so what? Who cares? Well, for one, these environments are all serverless, which means you have a very simple developer experience. You have auto-scaling to meet traffic up and down. You have HTTP triggers, where you have a URL that you can hit to make your function run. And then you also don't have to manage infrastructure. And I'd be kind of lying if I put a little green check in the bottom right box. You do have to manage a GKE cluster. It's still significantly easier than if you tried to do this yourself. But just be aware that if you want to do Cloud Run on GKE, you have to have a GKE cluster.
But there's a good reason for using, we haven't really touched on, for using GKE. It's like if you wanted to particularly use GPUs, say.
I'm going to get to that.
Oh, okay.
That's coming.
Oh, I think that's for your show.
Okay, so how do you think about these 3 different environments? First one, Cloud Functions, go from source code to a running function within minutes. I mean, what we just showed you is pretty simple. You write a couple lines, you issue a command, boom, you're good to go. Cloud Run, why would you want to do it on Cloud Run? Well, when you write that Docker file, you can put arbitrary stuff in there. It gives you fine-grained control over what actually goes inside of the container. Maybe you need a very specific binary. Maybe you need to have stuff built in a certain way. Well, if you write a Docker file, build it, deploy it to Cloud Run, you have an auto-scaling function that includes whatever custom stuff you need to put in there. So it gives you more flexibility, more power, a little bit more responsibility in terms of what you put into that Docker file, but also more power. Cloud Run on GKE, very similar sort of story. You can run it now in a self-managed cluster. Within that cluster, your function will scale up and scale down according to the size of your cluster, and that cluster can obviously grow too as your needs kind of change. But you can run it in that cluster with even more control. For example, you need specialized instance types like GPUs. Now you can have this function code that you wrote, deployed it to Cloud Run on GKE, where you have an instance pool that includes GPUs or more CPUs, specialized instance types, and your function can use those resources. And so this is a pretty cool way of thinking about the portability aspect, is I can write my function code once and I realize, hey, I actually need this specialized thing. Okay, well, I can move it to Cloud Run and I can do that. Maybe I need something even more specialized. I can move it to Cloud Run on GKE and I can do that too without needing to change my function code. As we start to wrap up, I just want to highlight that this is just a first step. What we showed you here is just Node 10. I'm sure a lot of people in the audience also want Python, Go, Java. All of the runtimes that we support on Cloud Functions, the new ones that we're going to be releasing, are based on this functions framework model that's going to give you that nice local developer experience. It's going to give you that portability to different cloud environments. Hey, one thing I should call out too is I showed Cloud Run on GKE, and I mentioned earlier that these are Knative environments. There are other Knative environments provided by companies that are not Google. IBM, for example, has a Knative environment. The container that you build can run on that environment too. So this isn't just portability within Google Cloud, it's also portability among Knative environments provided by other providers.
Or even on-premise.
Yes. You can run Knative in your cluster on premises, and you could run your function there. So back to the runtimes. All new runtimes that we're going to be releasing are going to follow this model. It'll give you that local developer experience. It'll give you that portability. Python, we're planning to, when Python 3.8 comes out, that's going to be a functions framework-based model. We also see this functions framework as a great way that we can start to integrate additional functionality into your functions. So one example here is I want to be able to see my trace data. Imagine I have 3 or 4 functions calling each other. I want to see the life cycle of a request as it passes through those different functions so that I can see which one takes the longest, where does this thing get caught up. We can add those things to the module that is the functions framework so that in each language you suddenly get this functionality for free built in. And when I say free, like these services do sometimes have a cost, but I mean that you don't have to actually add this boilerplate code to every one of your functions. It just comes nicely integrated. And then also, a lot of the talk today was based on HTTP. We also support events, so an event-style signature. And we do have more work to do on bringing these events to other platforms. But we're working with the CNCF, which is the Cloud Native Computing Foundation's Cloud Events spec. So we support that today. If you send cloud events to the functions framework will automatically convert those into objects relevant to your language. And these are the pieces that we think are really key to providing a good functions experience. It should be easy, it should be well integrated so that you don't have to write a bunch of boilerplate, it should support events, obviously, and we think we can do all of this through the functions framework. So with that, as we wrap up, there are a couple of sessions that I'd point you to if you want to learn more about what you saw today. Most of these have already happened, but they're going to be up on YouTube as well if they're not up already. So what's new in serverless compute goes much more into App Engine, Cloud Functions, Cloud Run, what's all the new stuff. Some really cool demos in there too that show us scaling up from 0 to almost 10,000 instances to handle a request load within like 5 seconds, which is pretty mind-blowing. We also have a Cloud Run session, which will go much deeper on how you actually use this product, what are the features, and a Cloud Run on GKE session, similar, but about Cloud Run on GKE. So with that, I want to say thanks. Some links here. This is all going to be up on YouTube if you need to capture those later. Cloud Functions docs, also the Functions Framework repository, which is live today on GitHub, and the Cloud Run docs, great ways to kind of get familiar with the products. Your feedback, greatly appreciated. As I said at the beginning, please add it to the app. Tell me what you liked. Tell me what we can do better next time. This is super helpful to me. And I will leave these private alphas. These are QR codes for the Go 112 runtime and the Java 8 runtime. These will lead you to forms. If you fill those out, we're adding people on a weekly basis. We can add more people. We can get you added to those as well. And if you missed these, come get me later. They'll also be on the video that's hosted on YouTube.